The last thing we're going to look at for this chapter is measuring temperature, where this is looking at how hot or cold an object is. And traditionally, both in terms of history and today, the main tool we have for working with this is the thermometer, where thermometers are built on the basic thermodynamic and fluid principle that if you heat something up, it will expand, and if you cool something down, it will contract. So you put some sort of fluid into a sealed tube, stick it into your tea. If the thing shoots out the top, then you know it's very hot without having to burn your tongue. However, these weren't always standardized. They didn't all have the same printed scale on them, they weren't all made from the same materials, and thus what one person used to measure temperature might have varied a fair amount from what another person may have used, and it caused some problems there in terms of being able to actually tell how hot and cold things are, though Huygens suggested building off of the freezing and boiling points of water in the 17th century, where the big breakthrough in this field, the field of thermometry, was the invention of the mercury thermometer by Daniel Gabriel Fahrenheit in 1714, where by 1724 he would propose a standard scale built around a kind of odd string of values. The temperature of a mixture of ice, salt, and ammonium chloride, which was supposed to reach an equilibrium of 0 when properly mixed, so that was the bottom of the scale. And the approximate, at least the approximate at the time, temperature of the human body, which was thought to be 96 on that scale, so you can have that division by 2, it's split by 48. It's the exact nature of where Fahrenheit set his values, it's a little bit hazy, but those are the best understandings that we have today, where if you want to talk about when water boils, for example, that ends up being at about 212 degrees Fahrenheit, but his system was definitely better than having none at all that was consistent, so in its time it was adopted by the British, and today the Fahrenheit temperature scale is still used by the United States, along with Liberia, Belize, Palau, the Bahamas, and the Cayman Islands. Weird little collection, if there ever was one, where, as with converting to metric, there's just a lot of inertive force of laziness to stop people from switching to a perhaps more logical, or at least more commonly used system than the Fahrenheit scale, although some argue in America that keeping the Fahrenheit scale is better for people's everyday uses because we are better at understanding the difference between single digits and decimal values that occur with other different systems. And I'd argue that's because it's what we work with. It's sort of circular, but that's just me. Anyway, Fahrenheit scale, despite still being used by a fair number of people today, is obviously a bit funky, a bit weird. So the other scale that came about afterwards that most of the world uses is the Celsius temperature scale, put together by Anders Celsius in 1742, where he took inspiration from Huygens, setting 0 degrees Celsius as the boiling point. That is, 0 degrees Celsius is the boiling point of water, and 100 degrees is the freezing point, with units referred to as centigrade. Now, over the next few years, it's depending on whether you look at Norwegian sources, not Norwegian, Swedish sources, Scandinavian generally, or French sources, you'll hear different people who switch that scale around, but it did end up flipping around to be 0 as the freezing point and 100 as the boiling point. But it did switch, and over time, people began to take Celsius's name as the reference there, so it wasn't just degrees centigrade, it's also degrees Celsius. Either works for reference with that scale. It's actually interchangeable, and these would become the main units used by much of the world in the 19th century, specifically through the scientific community, where, as a result of the same conference that reset the weight of the kilogram in 2018, the Celsius scale through the Kelvin scale, which I'll talk about in a second, was reset around the Boltzmann constant, where, for our purposes, if you want to convert between the two main scales that are used in everyday life, Fahrenheit and Celsius, you do so in terms of two options. Either you go from Fahrenheit to Celsius, by taking your Fahrenheit value, subtracting 32, and multiplying by 5/9, or you go from Celsius to Fahrenheit by multiplying the Celsius temperature by 5/9 and adding 32. So actually in either case, you can get a pretty quick approximation that we'll talk about by working in terms of adding or subtracting 30 and then multiplying or dividing by 2, depending on where you're coming from and where you're going. But those are the concerns of people with examples, which will be you soon enough.